moving along, let's now look at the length of a line segment. So how long is an actual line? Suppose I gave you these 2 points, 3,2 and 3,9. Can you find the distance between them? So feel free to pause the video here and see if you can find the distance between these 2 points. Okay, so hopefully you're back. If I was going to plot these points, 3,2 would be here, and 3,9 would be here. So the length of the line that I'm looking to find is between here and here. And we can find this. This is just a simple count. So I started at 2, I ended at 9. So 1, 2, 3, 4, 5, 6, 7. So my distance is equal to 7. All right, let's try another one. That obviously a little too easy. Let's try this one. What if I asked you to find the distance between these 2 points, -2 and 2 and 6 and 2? Can you find that distance? Pause the video, take a moment, come on back. Okay, so if I was going to plot these points, -2 and 2 would be here, and 6,2 would be here. And so my distance that I'm looking for is between here and here. And again, it looks like this is just a simple count between -2 and 6. So 1, 2, 3, 4, 5, 6, 7, 8. My distance equals 8. So when we have vertical and horizontal lines, it's easy to count what the distance is between 2 points because it's a nice flat surface or it's up and down. It's an easy count. But what happens when we have these kind of points? So this is at -1, 2, which is here, and then -6, 8, which is up here. And now if I connect these points, it's a little bit harder to figure out that exact distance because it's on this diagonal. But notice the title of this, make a right triangle. So let's go ahead and actually do that. Let's make a right triangle. Let me pull in something else here. So, ooh, I don't like that. So let's use, I was hoping to use like a straight line, but different color, but I'm just going to use a straight line. So if we make a right triangle, it goes there, and then it goes there. From there, we can count, right? Because remember we said before, if we have vertical or horizontal lines, we can just count. So 1, 2, 3, 4. Oops, 1, 2, 3, 4, 5, 6. So this side is 6. 1, 2, 3, 4, 5. So this side is 5. And we have a right triangle. And what do we remember about right triangles is we can always find a missing side from a right triangle if we use Pythagorean theorem. So on this side, we're looking for our hypotenuse. So this is the a squared plus b squared equals c squared. So if I go 6 squared plus 5 squared equals c squared, 6 squared is 36 plus 25. This is going to give me, nope, 36 is 61. And then I take the square root. And the square root of 61 is 7.8. So that means my distance between these 2 points, my distance must equal 7.1. So we had to use Pythagorean theorem in order to help us here. So that, but that will always work. If we can create this rise and this run, then from there we can create this triangle, and then we can use that triangle to help us solve for the hypotenuse, which is the distance we're looking for. Okay, so let's try another one. We're going to plot the points -3, -2, so that's here, and 6 and -9, which is way down here. And then I'm going to go like this. And then again, we can create a triangle here. So I'm going to create one like this, here and here. And there's my 9. And then I'm going to count, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7. And then I'm going to use Pythagorean theorem again. And I get 9 squared plus 7 squared equals c squared. 81 plus 39 equals c squared. 81 plus 49 is 130. Take the square root. And the square root of 130 is 11.4. So here's my distance. Between here and here is 11.4. Okay, so this is great, but I don't always want to have to put this on a graph, and I don't want to always have to draw these vertical and horizontal lines and then count. There has to be a better way without the graphing. And so let's develop a formula. So if this is the length of the line that I'm looking for right here, if I want to go between x1 and x2, how can I figure out that length? So let's go back here. So let's go back maybe even over to here. So when we found this was at -6, which was an x value. And it ended up at -1, but we got an answer of 5. And then from here, we had, or down here, I suppose, we had 2, and then we had up to 8, and then we had this answer of 6. So how are we getting an answer of 6? Well, notice, if I take 8 and subtract 2, I get 6. If I take -5 and subtract -1, I get -5, but it's still the same thing. It's still 5. So over here, I went from -3 all the way up to 6. And if I go 6 minus -3, I get 9. And from here, I went from -2 all the way down to -9. And notice if I go -9, subtract -2, I get -7, which is the same thing as 7 when it comes to squaring. So if I'm talking about the distance between these two lines, what I can do is I can take my, I always like to start with the second one, and the formula does. So distance is equal to x2 minus x1, and then whatever that number is, you're going to square it. And then plus y2 minus y1, and again, we're going to square it. And then remember, our last step is to take the square root. So this ends up being our distance formula that will help us figure out the distance between a line, between 2 points, without having to do all that graphing. So let's give it a try. Plot the points and then determine the distance between them. So -3 and 10 is up here, and 9 and 5 is right here. So I'm looking for this distance between these two lines. So this is x1, y1. This is x2, y2. And I'm going to use my distance formula. So x2 minus x1 squared plus y2 minus y1 squared, and then take the square root. So distance equals x2, which is 9, minus x1, which is a -3. And we're going to square that. And then y2, which is 5, minus y1, which is 10. And we're going to square that. And then we'll take the square root. Okay, so distance is equal to 9 minus -3, which is 12, squared. 5 minus 10, which is -5, squared. Well, 12 squared is 144, and -5 squared is going to be 25, because -5 times -5 is 25. 144 plus 25 is the square root of 169, and the square root of 169 is 13. So my distance between these 2 points is 13 units. So you give it a try. Pause it here, give it a try, come on back. Now remember, we are using our distance formula. Just write it out again. The number, if you keep writing it out, there's a better chance you'll remember it without having to look it up. So x2 minus x1 squared plus y2 minus y1 squared. So my distance is going to be -3 minus 4 squared plus 5 minus -9 squared. -3 minus 4 is -7. 5 minus -9 is 14. Okay, -7 squared is 49. 14 squared is 196. Plus 49, which is 245. So my distance is the square root of 245, which is 15.7. So that is my distance between these 2 points. Okay, this just takes a little bit of practice, finding the distance between 2 points, but I'm sure you can do it, especially now that we have this formula that we can use. So give it some practice, and if you have any problems, come on back and talk to me.